So again, on the second part, we are solving systems of equations. If you have the two equations and you can graph them, you can visually see where they intersect, and that point is the solution to both equations, and so that would be your solution to the systems of equations. So most of the time, that's what we're looking for, is the point that's on both of them. If they're parallel, of course, then there's no lines no points that solve it. There's no solutions, and if they're on top of each other, then there's infinite solutions. So when we're solving these, here are my two equations. Here's another method to do. Yesterday we did the elimination method where we stacked them up and we added them together and got rid of one of the x's or got rid of the y's. Today, if one of the equations is already in y equals or x equals, then this is where we're going to substitute. This is literally what y equals right there. So where the y is, I'm going to substitute that in. So I'm just going to rewrite this one, 2x plus 4 parentheses, and I'll make a parentheses where the y is, equals 0. And what is y equal to? Y is equal to negative 8x. And now I have a single equation with only x's in it. So if I just go ahead and simplify this and solve for x, 4 times the negative 8 is a negative 32 with an x with it, right? Equals 0. And then I can add these two together. 2x and negative 32 means 2 of these killed 2 of those. So now I have a negative 30x equals 0. And of course, if I divide by negative 30 to get x by itself, because that's the whole goal, is to solve for x, get x on one side by itself. 0 divided by anything is 0. So x is equal to 0. So at this point, where the two lines intersect, the x is 0. Voila. The second part of this is just like yesterday. Now that I know the x, I can plug it back into either one of the equations. And I'm thinking the first one looks like an easier equation to plug into. So y is equal to negative 8 times my x. And what do I know x is? X is 0. Y is equal to 0 because negative 8 times 0 is 0. So the point where the two lines intersect is the origin, 0, 0. So if I plug in y is 0 and x is 0, it's true. Plug in x is 0 and y is 0, it's true. Those are the two numbers that will make that system true. So here we go. And again, solving the systems of equations, looking for where the two lines intersect. Since one of them is already in y equals format, I'm just going to plug it into where the y is. So 6x plus 7 times my y is equal to 20. And what is y equal to? It's equal to 2x. So I just plug it in here. Now I have an equation with all x's. Simplify. 7 times 2 is 14x equals 20. Combine my like terms. That gives me a 20x equals 20. Divide by 20 to get x by itself. X is equal to what number? It is equal to 1. So where these two lines intersect, the point where they intersect, the x number is a 1. Now that I know one of my numbers, can I plug it back in? Sure, I can pick either equation. I'm thinking the second one looks like a whole lot easier to solve than the first one. So y equals 2 times x, and x is 1. See there, x is 1. And of course, y is equal to 2 because 2 times 1 is 2. So the point 1, 2 is where those two lines intersect. When x is 1 and y is 2, those numbers will work for both those equations. See how easy these are? You don't need a graphing calculator for this stuff. Again, one of the equations in the systems is already in y equals, so I'm just going to plug that in where the y is and go solve for the variable. So 3x is equal to negative, oops, there's not negative, 3x minus 5y equals 6. There we go, and the y is a negative 3. So if I just simplify this math, negative 3x and negative 5 times negative 3 is a positive 15 equals 6. Subtract 15 on both sides, right? That's what we're doing here. Negative 3x is equal to a negative 9 because the bad guys are going to win. Divide by negative 3, divide by negative 3. X is equal to, this is a positive 3. So x is 3 in this one. So now all I got to do is find the y number that goes when x is 3. And again, well, I can't really plug it into this one because, and if you think about this, y is negative 3. So if you want to, you could plug it in right now. We know y is negative 3. But if you want to do it in the other one just to see how it works, negative 3 times the x minus 5y equals 6. So if I want to just double check it, 3 is my x. That gives me a negative 9 minus 5y equals 6. Add 9 to both sides. Negative 5y is equal to 15. Divide by negative 5 on both sides. And y is equal to a negative 3. And in this equation, does it say y is always going to be a negative 3? Yep. And so if you look at that particular equation, all the y's are negative 3. But anyway, 3, negative 3 is the point where those two lines intersect. Again, y is negative 8. So guess what? In this equation, y's are always going to be a negative 8. So the negative 8 is going to have to be the y number. So if we wanted to, let's go plug in negative 8 where the y is and see what x is. 6x minus 5, and here's my y, right, equals 22. So I know y is negative 8. That's what I'm plugging in for the y. So simplify. That's going to be positive 40 equals 22, and I still have the 6x sitting in front. Get rid of this by subtracting. 6x is equal to, what is that going to be? I'm going to take that away, so that's going to be my negative. I'm double checking my math here on this one. This is number 12. Yeah, that's 8. Oh, that's right, I plugged in. I forgot what I plugged in on that one. Oh, I'm sorry, I was looking at the wrong thing over here. Okay, so negative 18, I'm on the right one. I was looking at the wrong problem, looking at the math, going, why is that not working? Okay, so divide by 6, and of course x is equal to a negative 3. So now x is negative 3, and we already know the y is negative 8. That's the point where the two intersect. Again, two equations. I want to know where they intersect. I'm solving the systems of equations. Since one of the equations is already in y equals format, it's easy to take that piece and just plug it in for the y. So 3x plus 3 times 2x is equal to negative 18. I just took what y was equal to and plugged it in right there. So distribute 3 times 2 is 6x, so I have 3x plus 6x is equal to negative 18. Of course, that's 9x equals combining like terms. Divide by 9 to get x by itself. X is equal to a negative 2. So where these two lines intersect, the x is a negative 2, I just need to find the y number. So again, if x is negative 2, plug it into one of these equations, and that one looks easier to solve. So y equals 2 times x, which is negative 2. And that is y, it means y is equal to negative 4. So there's the point where they intersect. X is negative 2 and y is negative 4. That pair of numbers will solve that system of equations. Okay, so last one. Again, the y is already in y equals format. Actually, there's two more. It's already in y equals format, so I can use the substitution method. That's what they call this, because I'm going to substitute this in for the y. So negative 5x minus 5 times whatever the y is equals 0. Sometimes y is a big messy thing, but this time they're really nice and simple for you. So if you distribute this, it gives you a negative 40x, 0, and this is a negative 5x. And of course, you can combine that together. You have a negative 45x equals 0, combining like terms. Divide by negative 45, divide by negative 45. 0 divided by anything is 0. So my x is 0. So let's go plug it back in. When x is 0, y equals 8 times 0, because my x is 0. And of course, 8 times 0 means my y is 0. So this one also intersected, those two lines intersected at the origin. Last one down here, again, a systems of equations. We're looking for the two lines intersect, doing it algebraically. If one of them is already in y equals or x equals, I'm going to substitute that in for the y. So this is a negative 3x minus y equals negative 24. And what is y equal to? 3x. Now, that's negative 3x minus 3x, that's negative 6x. Bad guys and bad guys equals negative 24. Divide by negative 6 to get x by itself on both sides. X is equal to a positive 4. So where these two intersect, the x is a 4. I'm thinking the first one looks easier to solve, so y is equal to 3. Again, I could use either one to plug in. But I already know the x. If I can make parentheses without moving the paper. There we go. So x is a 4, so this is going to go here because y equals 3 times x. And of course, y is equal to 12. Oops, I cannot write and talk at the same time. Let me try this again. Equals 12. There we go. I'm trying to hold the paper with one hand. There we go. So there's your solving systems of equations. Easy peasy, guys. You can do it without a graphing calculator.